very happy, sir, to meet you. And my question is very simple. Uh, First of all, I will give my introduction. I'm from physics department, and my name is Miss Songita Basmatari. And my question is, we have a syllabus called mechanics in our class going on, and I want to know your point of view to pursue it.
Mhm. So mechanics essentially is, I think, the field of physics that is the easiest. Why? Not because it has the least equations or anything, but because it feels the most connected to our world. In mechanics, you can figure out how a projectile will move. So if you throw up a ball, you can figure what's the maximum height, what's the time it will stay in the air, everything like that. Whereas, for example, in electromagnetism, most people will never see an actual circuit with a resistor and an ammeter unless they're doing, for example, an experiment. And even still, a circuit diagram isn't very intelligible. But you know exactly what you're dealing with when it comes to mechanics. You're throwing up a ball, or you're finding what is going on, or you're finding how fast a train moves, or you'll find how much force will impact you if you run into a wall. So those are the kind of things that you measure in mechanics, and they're very easy to actually view in real life. For example, if I throw up this pen right now, you can see that's already a case of projectile motion. So when it comes to actually understanding these, it's very simple as well. All you need to do is figure out what all the terms mean. I think you can already figure out what distance means. Velocity is, of course, just how distance changes over time. So essentially, if something is moving faster, it has a greater velocity. Something has a big acceleration, then that means it's getting faster as time goes on. And of course, this already seems pretty obvious to you, but what doesn't seem obvious might be the equations. Of course, how is this true? Well, because acceleration is just how velocity changes. So over time, which means, of course, the velocity final minus the velocity initial divided by the time, which is essentially the average change in velocity over some unit time, going to be acceleration. In the same way, we might ask, where does this come from? V naught plus V naught t plus half at squared. Well, this is pretty easy too. It's kind of just a little bit of calculus. All you need to do is, of course, acceleration is equal to, oh wait, okay. So all we really need to do here is, of course, this just says that the change in distance is equal to the initial velocity times time plus half the acceleration times time squared. So what happens if we take the derivative here? Well, if we take the derivative over time, all that happens is, this is, of course, a constant. This becomes v naught, and this becomes half at. So this is basically the exact same thing that we saw over here. And then what happens if we take the derivative again? Well, we just get a. So of course we can technically put this here. It's just a constant of integration. But essentially what we're saying here is just that. Think about what happens if this is 0. Then we are just accelerating from rest, and we'll get something that exponentially increases. And even this only adds a little push to it. So instead you'll get this instead of, for example, this. So these are mostly how mechanics works. So force, for example, is just how much acceleration you give to something with a mass. If that object is heavier, you will have to exert more force to make it move the same at the same rate. So you'll also learn about rotational mechanics, which is essentially just an analog to regular mechanics. You'll learn about momentum. Uh, you'll learn about kinetic energy. Oh wait, this is. And you'll learn about so much more. But it's all intuitive if you actually take the time to understand, draw a diagram, figure out different cases, etc. So mechanics is typically the first subject that you approach in physics, but it's very intuitive. So all you have to do is know what every single thing means. Don't just write down the symbols.
Sir, I have one more question. We were talking about black holes, and I have this question on my mind always. What is there inside black hole?
Okay, so
Yes,
that's a wonderful question, but of course, it's everything that the black hole sucks up, massed into a gravitational, into just some sort of information soup. So essentially, it's super compressed because of the gravity of the black hole. So essentially, all that's inside the black hole is very compressed matter that's left over from whatever it sucked up. And of course, the accretion disk around the black hole is matter that was traveling so fast that its centripetal force is enough to resist the centrifugal force is enough to resist the force of the black hole.
thank you. Thank you. So let us now move to mathematics. So Firdosi Nuri, please ask your question. So from physics, Professor Wari, now it's mathematics question. Three questions you will have. Come to the come.
Mhm.
Hello, Professor Ravi. So my name is Fidosi Nuri, and I am from the mathematics department. So my question is, let f is a function from the open interval 0, infinity to real number r, satisfying f x y equals to f of x plus f of y for all x comma y belongs to the open interval 0 to infinity. If f is differentiable at 1, show that f is differentiable at every c belongs to the open interval 0 to infinity.
Okay, let me just.
Oh, yes.
Okay, so let's see. The first one. Okay, got it. So you've got a function that satisfies this for all positive numbers. You have to show that if f prime of x exists at 1, then f prime of x exists everywhere. So what I'm going to do firstly is replace x and y with a and b, because otherwise they're very easily confused with the x and y that we regularly use. So f of a times b is equal to f of a plus f of b. So then what would it mean to actually take the derivative? What would it mean to actually take the derivative of this? Well, what I'm going to do actually is what happens if we take, for example, f prime of a, b. So let me think about it. Yeah, okay. So it should just be that f prime of a, b is equal to f prime of a plus f prime of b by this rule. So let's try this out somehow. Let's see. Of course, this works with 0 because f of 0 is equal to 2f of 0, which means all of it is 0. So what I'm going to do is, mm, we clearly know that if we test anything out, f of 1 times 0 is equal to f of 1 plus, wait, let me see, is it an open interval? Oh, yep, it's an open interval. Okay, never mind. So we can't use 0. So Okay, so what I'm going to do instead is we're going to, let's see, test out both 1. F of 1 is equal to f of 1 plus f of 1, which obviously means that f of 1 is equal to 0. But of course, if a is equal to b, then this is going to be a times b equals a squared. So what I'm going to do is I'm going to say f of x squared is equal to 2f of x. Wait, yeah. And now what we're going to do is we're going to take the derivative via the chain rule, which gives us f prime of x times 2x, f prime of x squared times 2x is equal to 2f prime of x. So essentially, f prime of x squared is equal to f prime of x. So, of course, if we plug in 1 to this formula, we get f prime of 1 equal to f prime of 1. Which means that if this is true, and the derivative exists, then this formula is valid for any, what? Okay. Okay, there we go. So this formula, oh my gosh, f prime of x squared is equal to f prime of x. There is no point in the positive real numbers where this is undefined. Because, of course, this is a real number, this is also always a real number, and this is also always a real number. So, in the same way, we can take this. So essentially, if f prime of 1 exists, which proves this equation true, because f prime of 1 is equal to f prime of 1, then if f prime of 1 exists, this equation is true, which, since this equation is valid for all real numbers, then that means that it exists in all real numbers. Wait, let me see. Okay. If f prime of 1 is equal to 2, then find the nth derivative of f at 3. So let's see. So if f prime of 1 is equal to 2, what does that mean? Well, that means that, let me erase this. Oh. Okay. So if f prime of 1 is equal to 2, what happens if we plug this in? Well, oh wait, f prime of 1 equals f prime of 1. We're hit with a dead end. So instead, what I'm going to do is try and plug a different equation in. Say, for example, let's see. Why don't we do something like f of a plus f of 1 over a? Yeah, that would work. So f of x plus f of 1 over x is equal to f of 1. So of course, taking the derivative on both sides, I'm just going to get 0. Oh, never mind. Okay, wait, no. Wait, yeah, never mind. So how are we going to get f of 1? That's f prime of 1. That is a great question. So let me think. Oh, actually, maybe this should work. Plus f of 1 over x is equal to f of 1. So we take the derivative, we get 0 over here is equal to minus 1 over x squared, and then f of x, f prime of x. So now that means that 1 minus 0, oh. Okay, so how do we find f prime of 1? Well, let's see. Is there anything else we can attempt? Or anything similar to this we can find? Well, okay, let's try. Oh, I've got an idea. We can obviously find anything we want with this besides 1. Because, for example, we get f prime of 2 is equal to 2 f prime of 4. Oh, great. Okay, so let's see. Okay, what I'm going to do is I'm going to plug in the square root of 3 here to get rad 3 f prime of 3 is equal to f prime of, is equal to f prime of root 3. And here's the thing, we can infinitely differentiate with this. Okay, so infinitely differentiating though is very hard because then we'd have to use the product rule. So we'd have to use something like this. Oh, excuse me. And of course, this is going to become a huge mess if we continue. So let's see. Uh-oh. What can we do to keep this going? Well, okay. Our mission is just to find under what conditions f of 8 times b is equal to... Under what conditions is f prime of a... f prime of 1 equal to 2? Well, I have a sort of an idea. So what I'm going to do is I'm going to take... Let's see. We're going to just say a is a constant and b is x. So then we get a times f prime of ax is equal to this plus f prime of x. So then what happens if... No, I don't... Let me see. If we get a f prime of a is equal to f prime of 1, oh, that might actually be useful. We already know this is 2. So if a f prime of a is equal to 2, then... Wait a second. So then we get a f double prime of... but then once we take the derivative, this side is going to be equal to 0. So let's see. So I had sort of an idea there. Let's see. Oh, I think I got it. So let b be x to the n. So this is equal to f of a plus f of x to the n. This becomes, of course, nxn minus 1 f x to the n minus 1. No, n. F prime of x to the n. And this is going to be what? Right. A times nx n minus 1 f prime of ax to the n. And of course, these would cancel out. That's a pickle. Okay. So it looks like we can find this first derivative, of course. F prime of 3 is equal to 2 over 3. But then maybe we have to utilize this to keep moving forward. But this gets increasingly difficult as time goes on. Of course, you could plug in and pray that it works. So let's see. You get 1 minus 2x squared is equal to... Wait. Oh, what I could do to simplify this is say we can just sub in a new variable. So this is 2x, f prime prime of x, plus f prime of x is equal to f prime prime of x. Great. So now I'm going to erase this, which was in the center. And we're going to write that f prime of x is equal to 1 minus 2x f double prime of x. And now we can do this. Taking this next derivative gives us minus 2 on the outside. Oh, wait a second. Oh, then I think we must use the product rule again. But it shouldn't be too hard. So 1 minus 2x. Next one we get is this. And then plus, let's think, 1 minus. So there's clearly a pattern here, of course, but I'm struggling to see it. So this becomes 1 minus 2x over 3. But does the pattern continue? It might be a half factorial kind of situation. Let's see. Oh yeah, the pattern will probably continue, but just to be sure, if we take the derivative of this, now it gives us minus 2 over 3. So then f triple prime of x plus whatever else is there. So then we get 1 plus 2 over 3, which is obviously 5 over 3. Oh, this is difficult. Okay. So let's see. Oh, what the? Okay. So I'm trying my best to get this done. Let's see. So this is going to be equal to 5 over 3. I think I'll just keep the coefficients here, honestly. 3 f double prime of x is equal to this. 5 over 3 f triple prime of x is equal to this. When we take the derivative of the next one, we get, well, okay, this is going to keep continuing. So what happens when we actually plug in and get all of this done? Well, if we plug in 3, we get 1 minus 6. This is negative 5. F prime prime of 3 is minus 5. F prime prime of 3. And of course, we know this is 2 over 3, which means 2 over 3 is minus 5 f prime prime over 3. Or in other words, f prime prime over 3 is equal to minus 2 over 15. Then, when we plug in this over here, what do we get? Minus 2 over 5 equal to minus 5 f triple prime of x, which means f triple prime of 3 is equal to minus 2 over 25. Then, once we multiply it by this, we get 2 over 15 here. So f quadruple prime is going to be minus 5, 2 over 15, which is going to be minus 2 over 75. So how does the pattern actually continue? That's the question. Because clearly there is a pattern, but I don't seem to be getting it very much. So let's see. No, don't move on to the next question. Okay, so let's see. I'm going to do one final check with the fourth derivative. So of course you take the derivative on both sides and wait a second. This is wrong. This is all wrong. Oops. We take the derivative of this. And then we take the derivative of this again. And we get... Oh... Well, that explains quite a lot. Okay, so this problem is a lot easier than I thought. Is equal to... So essentially, it's a recursive relation saying fn of x is equal to 1 minus 2x times fn plus 1x. And of course, there's something over here, which is going to be 2n minus 1, which means we have a good recurrence relation. Because now we already know if we plug in we already know f prime of x, uh, f prime of 3 is equal to 2 over 3. And now all we have to do here is plug in 3. So this is now, don't worry, we're almost done. This is now 3. This is now negative 5. And this is fn plus 1. So essentially, fn plus 1x is equal to, let's see, 1 minus 2n over 5 of, wait, is that right? Yeah, should be. Over 5 of fn of x. So, and of course, this is going to be 3, not x. Okay, so I got it. Fn plus 1 of 3 is equal to 1 minus 2n over 5 of fn of 3. So, of course, this keeps going up. We start from n equals 1, and we just keep going. So this gives us a value for every term.
Thank you. So, giving the round of applause.
This is the mind of 12 year old. And he started calculus when he was 2 and almost finished the calculus when he was 4. This is the mind of 12 year old.
Okay, thank you. So, I mean, the next